Bismillahirrahmanirrahim. Assalamu alaikum everyone. This is Hamayu and I'm back with a new video after a long time. I've been receiving a lot of requests for the QVAR. So in today's video I'll be specifically talking about the QVAR model, how you're gonna run it, and how you're gonna prepare data for it and how it works. So this video will be a detailed one as compared to my previous video on the TVP-VAR. So let's move on before further ado. So what are the packages that we'll be needing for this? Actually, we'll be needing three packages for this: the read Excel, the zoo, and connectedness approach. Let's run one by one. Click wherever you want inside the function and then click on run. So it actually run. You can see here in the console, and then the zoo package, and then the connectedness approach. Okay, so now we have loaded all these three packages that we require for the QVAR. The next phase is actually reading the data, right? So if you have a data in the CSV format, you don't need to run this code. For that there is a function read.csv, but I have my data in the XLSX format, so I'll be using these read_xlsx. I'm naming it as my data. My data is equal to read_xlsx gbret.xlsx. The name of the data in the directory is gbret. So these are actually the green bonds returns, so I've named it as the gbret.xlsx. So let's run it, gbret.xlsx. I've named it as my data. Okay, so it has been loaded. So before moving further, let's check this data first. So I'm going into the console and let me show you how this data looks like. So view my data. Okay, so now a new window has popped up. So we see that I have a date column, and then I have the returns of all the variables that I have in this data set, different indices of the green bonds, and I have the level, slope, and curvature of the yield curve. Okay, so let's move on to this QR model again. So now I have this data. The next step that is important, in order to run any of the connectedness approaches, whether it's a TVP-VAR or QVAR, is that you have to change this data into the zoo format. So in order to change it into the zoo format, first we need to separate this date variable from the data. This date variable, first I'm naming it as the date uppercase letters. So if you see, it's DATE, date is equal to my date $data. So I've extracted it. Now in the second attempt, you have to remove this date variable from the my data. I've already extracted this date in the name of DATE in the uppercase letter. Now let's remove it from the my data. So for that, what you have to do, just write my data and then these brackets and these square brackets and comma. After a comma you just put -1. It's on the first position of the data, as I showed you in my data. If you see, the date is on the first position, that's why I'm writing it as -1 after comma. So it will remove it. So now it has been removed from the my data. I can show you as well. Once again, view my data. So if you see, now we don't have any date variable in it. Okay, so now the most important thing, we have already libraried this zoo package. So let's convert this my data into a proper zoo format. I'm naming this data, this newly converted data into the zoo format as my zoo. So my zoo, so for that we'll be needing this zoo function ZOO, and inside that we'll put this my data, and order.by is equal to date, the same date variable that we extracted from this my data before deleting the date from the my data. So let's run it. Click on this. Okay, so now if you want to see my zoo, you can also see that. View my zoo, you can. Okay, so if you see here, it has been converted into zoo format. If you see, the date variable has been converted into the row names. So now the most important thing, that is running the connectedness approach with the QVAR model. So this is actually the function that you will be needing for it. You can note it down for your own analysis. So I'm naming this connectedness approach as DYC. Normally you see it, people name it with the DYC, which is dynamic connectedness. You can name it, you can give any name to it, ABCs up until Z or whatever you want. So So the function for that we'll be needing is the connectedness approach. Remember, we have a package connectedness approach, and in that package there is a function connectedness approach. So we'll be needing this connectedness approach. So in this connectedness approach, the first argument that it requires is the name of your data, which is actually my zoo. Okay, and the next argument is the number of lags. So by default it takes 1 as as a lag. So if you run the AIC and SIC or BIC on the basis of VAR, so you might get a different value, you might get a different value as well. So by default we get 1, and 4 is actually for how steps ahead you want to predict. You can give any value to it according to your data, but by default people normally use 10. Window.size is actually the rolling window of the regressions, of the VAR regressions. So if you have a daily data, then it is recommended that you should use 200 as a window size. But if you have a monthly data, you might, if you have a very lengthy data set, more than 3 to 4 years, and if you have monthly data, you might take it as 12 or 24, whatever it is. But for the daily, it is preferred to use 200. Okay, so corrected, we don't need this argument actually. If you don't want to use this argument, you can, but if you want to skip it, you can skip it. The next important argument after this is actually the 6th argument, which is the model. Obviously we are using the QVAR. So inside, so you just have to write model is equal to in these in these semicolons you have to write this QVAR in these commas. Next is connectedness. In this connectedness approach, you can have multiple types of connectedness. Like we have extended joint connectedness, we have frequency connectedness, and we have time connectedness. Normally we use time connectedness. So in this connectedness, you have to pen down as TIME, time, with the uppercase letter of T. Okay, the next argument is very important. This argument is actually in the form of list. So first you have to write VAR underscore config. Connectedness approach normally gives you this VAR underscore config is equal to list. Then under this parenthesis you have to write QVAR is equal to list, and inside that list you have to write TA, which is actually the percentile or the quantile. That is on the basis of which we call this as a QVAR, quantile vector autoregressive connectedness approach. So you can give any value according to your data. For example, if you want to calculate the fifth percentile connectedness, so you have to put it as 0.05. So this is actually the connectedness of the QVAR. Let's run it. Just click anywhere inside inside the function and click on run. Okay, it has started working. Normally QVAR takes a lot of time, so you have to be patient for it. Okay, it has worked. It has actually calculated the QVAR for us. Now let's see what do we have in this DYC. Okay, so let's see what do we have in it. So let's see first the table of the connectedness. So you have to just write DYC and then click on the table. So this is actually our table of the connectedness. You can save it however you want. So this is the table of the connectedness. Let's plot the network plot of this. So for that we have a function plot network and just put DYC inside it. See, this is the plot of this. So this is the plot network. You can plot other as well, like plot TCI, which is the total connectedness index. Put DYC in it. So this is the plot TCI. There are other plots as well. Plot from, put DYC. It will calculate the connectedness, the spillover from the system into the specific variables. So this is, you can plot other things as well, like plot 2. So put DYC inside it. So this is plot 2, which is actually the connectedness, the spillover from the system from specific variable into the system. So from the system to into the system. This is all about this QVAR. I hope you all would love it and you would like it. If you have any queries, please put your comment in my videos. I'll respond. So that's all. Thank you very much for watching this video. Thank you.